Hello everyone, I welcome you all to this lecture. In this lecture, we are going to discuss JK flip-flop. In the previous lecture, I have discussed SR flip-flop. So if you look at the truth table of the SR, when we set S and R, both the inputs as high, then the state which it generates, you can say it is unpredictable or undesirable. So to overcome that situation, we have JK flip-flop. So let's look at the circuit of the JK flip-flop. So in this is SR latch, which we have already discussed in the previous lecture, and this is the clock which we are using to regulate the behavior of this flip-flop. Now there is only one difference as compared to the SR flip-flop. This output Q bar is being connected as input to this NAND gate, and this output Q is getting connected as input to this NAND gate. So let's draw the truth table for JK flip-flop and try to analyze the behavior of it. So when we want to draw the truth table of it, the very first thing we consider, let's say, clock. So clock should be high for this circuit, then only the states can be modified. If clock is 0, it will preserve the previous state only. So clock is there, and then J and K. So J, K, and based on these things, we can predict the Qn plus 1, that is the new state. So we can predict the new state of this flip-flop. Now let's say clock is 0. In that case, if clock is 0, J and K will become don't care, whatever the value J and K will have. This Qn plus 1, it will preserve the previous state, so it will be Qn. It will act as memory element. Okay. But in case clock is 1, if clock is high, and let's say J and K both are 0, because J and K will have 4 different combinations, so 0, 1, 1, 0, and 1, 1, and clock is high in all these situations. So let's say the very first case, this one, when clock is high and both J and K are having value 0. So let's analyze this case. So let's say this J is 0 and K is also having 0, and this clock is 1. Now if this is 0, this NAND gate, the property of NAND gate we are aware about, if any of the input is 0, this NAND gate will generate 1. So here we will get 1. Similarly here also you will get 1. And this is SR latch. So we have already seen the SR latch. In case we construct the SR latch with the help of NAND, then when we pass 1, 1, it will preserve the memory state. So in case it was Qn earlier, in this case also we will get Qn, and it will act as memory only. Okay, now let's look at the next case. So in next case, we are having clock as 1, J is 0, and K as 1. So let me clear this. When you are having, so clock is 1 So this is 1, then j is 0, and k is, let's say, given as 1. So if this is 0, whatever these remaining inputs are, this line will give us 1. Okay, and if this is 1 and this is 1, this value, if you can predict what this value will be, so in that case, if you predict the behavior of this, like if you are having this as 1 and this input is, let's say, q bar, so this is 1 dot q bar whole bar, so in that case you will get q here, right? But in case you are having here the value 0 1 and this is coming as q, so this will give you q bar here, so this is q bar and this is q. So in case you have q bar dot q complement, this will give you 0, and 0 complement, it will give you 1, let's say, in that case. So this is 1 and this is, you will get 0, because this 1 will propagate here and then you will get 0 here, right? So in case this k is high and j is low, the output which we will get, that will get 0. So q n will become 0. In that case, k is high and j is low, right? So let me clear this. In case we are having third scenario, so in third scenario, what is given here, this is the third one. So where clock is high, j is high and k is low. So clock is high, j is having value 1 and k is having value 0. So in case this is 0, here we will get 1. So we are having this 1, right? Now with this one, if this q is coming, let's say q, so you will get here what? So if you are getting q here, this 1 dot q complement, it will give you q bar. Okay, and this q bar is connected here, right? So this q bar with 1 1 will give you q bar complement, so you will get q here. So this q and q bar complement will give you 1 here, right? Because you will get q dot q bar complement, so this is 0 complement and the complement of 0 will give you 1. So that means this, if you pass this one here, 1 1 will give you 0. So in that case, this will give you value 1 high. Let me write a different color. So this value you will get q as high. Now let's look at the last case. In case of SR flip-flop, this 1 1 input is not allowed because this will generate invalid state. So let's test it here. What will happen? So please look at carefully. When you are passing both the input as this is also 1, this is also 1. So when you are having this is 1, clock is already 1. Now this q bar is coming here. Okay, so this is 1 1 q bar. So you can say 1 dot q bar whole bar, right? So this will give you Q only. This will give you Q only. Similarly here, you are getting this Q. So this is Q, and you have 1.1.Q whole bar. So this will give you Q bar. So when Q is coming here and this Q bar is coming here, so this value will give you, if Q is here and Q bar is here, you will get Q dot Q bar complement. So this will give you 1, right? And if you pass this one here, so Q bar and 1, you will get 1 dot Q bar complement. So this 1 dot Q bar, when you get here, it will give you Q. So in case this Q is coming here, and if you pass this Q here, this is Q, this is Q. So in that case, the saturated output you will get here, Q bar, right? So here finally we will get Q bar, and here we are getting Q only, right? So in that case, what we can say here is this is Q only, not Q bar. So new state we are generating here as Q, and new state here we are generating as Q bar. That means the previous output is getting changed, or we are getting the complement of the previously generated output. So this is a toggle state. So you can say we are getting here Q and bar. It is toggling. So in this scenario, the JK flip-flop toggle when J is having value 1 and K is also having value 1, right? So please do remember, the last case is important in case of SR and JK flip-flop. Rest 3 cases are same as compared to the SR flip-flop. So this is the toggling state. So in case earlier the Q was 0, when we pass 1 1 here, the Q will become 1. And in case earlier the Q was 1, and if we pass both the inputs as 1 1, the Q will become 0. So that is the meaning of toggling. Now if this is the truth table, so I'm writing this is the truth table. Now with the help of this truth table of JK flip-flop, we can draw the characteristic table. So let's draw the characteristic table of JK flip-flop. So I'm just copying this. Now let's say this is the truth table of JK flip-flop. Now draw the characteristic table. So in characteristic table, what we draw actually, we will have Qn as input. So let's say Qn is one of the input. Along with Qn, we will have J, we will also have K, and then we will predict the Qn plus 1 state, the new state. Based on these 3 input, we will predict Qn plus 1 state. So let's write it. Now when there are 3 variables, there will be 8 combinations. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So these are the These are the combinations. Now let's check when Q and S 0 and J and K both are 0. So in case J and K both are 0, in that case it works as memory element. So the output as Qn plus 1, we will get Qn, and that is 0. Now in case Qn is 0 and J is 0 and K is 1, that means it does not depend on the Qn. If K is 1, it will give you 0 output. So if K is 1 and J is 0, irrespective of any other condition, it will generate 0 only. Now in case the third condition is there, when J is 1 and K is 0, it will give us high. So when J is 1, K is 0, it generates high value, 1 value. When both are 1, 1, it will toggle. So let's say earlier it was 0, Qn was 0, now it will give you 1. It will toggle this particular value, that is 0. 0 will be converted to 1. Now this next case, when 0, 0 is there, it will preserve the previously generated state, memory element. So it will generate 1 because Qn was 1. When we are having 0, 1, so when K is 1, it will generate 0. So whenever K will get value 1 and J as 0, the final output state will be 0 only. So similar case, like when J is having value 1 and K is 0, it will give us high as per K. Now when both are 1, 1, the state will be toggled. So now Qn is 1, it will be converted to 0. So this is the characteristic table. So I'm writing here. So this is characteristic table of JK flip-flop. Now let's draw the excitation table. So let's draw the excitation table. Now in excitation table, we try to predict the value of J and K based on Q and Qn. So let's say I'm taking the value of Qn plus 1. So let's say it is given like Qn and Qn plus 1 is given, and based on Qn and Qn plus 1, we are predicting the value of J as well as K. So let's look at here. Now because there are two variables, it will have four situations. So 0, 0, 0, 1, 1, 0, 1, 1. So when Qn is 0, you look at here, Qn is 0 here, and Qn plus 1 is also 0. So this state and this also. So these two places, Qn is 0 and Qn plus 1 is also 0. So in this scenario, if you look at J is 0 and K is don't care. So J is 0 only. In both the situations, J is 0 and K will become don't care because K is changing from 0 to 1. Now if we look at the next case, the next is when Qn is 0 and Qn plus 1 is 1. So Qn is 0, here it is 0, Qn is 0, and Qn plus 1 is 1. And this is also Qn is 0 and Qn plus 1 is 1. So this is this case. In this case, J is having value 1 and K is don't care. So in this case, J is having value 1 and K is don't care. Right? Now the next thing, when we are having Qn as 1 and Qn plus 1 is 0. So let's clean this. Now look at when we are having Qn as 1. So Qn as 1 and Qn plus 1 is 0. So this is the case when Qn is 1 and Qn plus 1 is 0. And there's another case like this. So if you look at both these cases where J is don't care and K is 1. So J is don't care and K is having value 1. Now look at the last case. So what is the last case? In last case, when we are having both these ones, so here it is 1 and this is also, here it is 1 and qn plus 1 is also. So here it is 0 0 and here it is 1 0. So that means k is 0 and j is don't care. So j is don't care and k is 0. So you remember that this is the excitation table. This is the excitation table of JK flip-flop. So with this, I am ending this lecture. Thank you for connecting.